Hello everyone and welcome to a new video within the series of advanced sniffing and relaying. This will probably be the last one within that series. So the demonstration that I would like to show you today is about exploitation. So exploitation within the form of advanced sniffing, coercing, relaying and things like that. So if it's about exploitation, then this also actually means that we have vulnerabilities, because no exploitation without a vulnerability, otherwise you're just using the system as it is. And with exploitation, you usually also have like CVE codes and things like that, like common vulnerabilities. And one important part, although Microsoft might not always agree of exploitation and vulnerabilities, is patching. So things that I show today will be on older systems than the ones in the previous videos, right? So 2021 was a very very good year for exploitation and vulnerabilities and scripting and things like that on advanced sniffing, on spoofing, injecting, triggering, all these kind of traffic. I won't go into depth in this one, but this is still active today, as proven by the local potato vulnerability from 2023 for privilege escalation. But the one that I have selected to demonstrate to you today is actually the PetitPotam one, which still works on server 2019. It has been patched in server 2022, but the reason that I want to show you this one is because it does not require any prerequisite within the network. You don't need any privilege or access to or any username or password of the domain, the Windows domain that we will be targeting today. Okay, so without further ado, let's dive in. So what do we have here? We have two server 2019s. So these are also the prerequisites, the ones that the things that you are required to have before the PetitPotam vulnerability or exploit will work. And that is that you need two domain controllers. That's the first of two prerequisites. We have our main domain controller and we have our second domain controller right here within the same network. That's the first prerequisite, and the second prerequisite is that one of these actually has to have the certificate authority role with the web server enabled. So that means that within that domain, this machine, in my case, is the first one. This machine is providing a web interface where you can log into to send certificate signing request, CSRs, and then the CA, which is on the domain controller, signs that certificate and returns the private and public key as a single certificate to the requester. And what we will do with PetitPotam is we will coerce the second domain controller to perform a signing request to the first one, to the domain controller, and we will intercept it and relay it and get and reuse the certificates to get tickets, Kerberos tickets, and to pwn to hack the entire domain. So let's dive into it. So the first thing I did was actually to download the one thing that is not built into Kali that we need for this exploit, or one of two things, because we of course need the PetitPotam itself as well. So these are the PK unit tools by Dirk-Jan Mollema, very interesting tools to get some hashes and tickets. It's built on top of the Impacket suite, right? So we now install the requirements and together with some Python libraries of Mini Kerberos and OS Crypto. Okay, that's already done in a new window. So I will now start a new window and make it a little bit bigger, like this, where I will actually download PetitPotam. So it's now being downloaded as well. So it also assumes that you already know how the network works. But you already know how the network works and which machines are in here. So in this case, we have our main domain controller that is on IP45. We have our second domain controller on IP62. And if we want to look at our own IP address, it's 129. That's important for the remainder. So let's first verify if there is actually a web interface running on our domain controller, which is the main one, the 145 or the 45 one. So I perform a call request for this URL, and it's perfectly normal that it is unauthorized because you need authentication to be able to request certificates. Makes sense, right? So, but this actually proves that we have our CA web interface running. So I need to configure two things. We need our NTLM relay, which is something that we have seen before in this series. So it will relay any requests that are coming in. It just starts a listener. This does not do anything on its own right now, but it starts a listener, and it actually forwards any requests coming in for, well, all these things, but specifically certificate signing requests, and it will forward them to the domain controller in this web interface. So what we now need to do is to exploit the vulnerability, which is a vulnerability within the Windows Server share solution, where we can actually force or coerce the operating system to request a certificate. This is how it works. It's fairly simple. This is our own IP address, so it will perform a request to this IP address, and this is of course our target or victim. So this is the second domain controller in this case. It worked. It has performed the bound. It has exploited this pipe, so this request. And as you can see here, it actually worked. We have the request that has come in, it has been succeeded, has been redirected to the primary domain controller, which has received the certificate signing request, and then he has signed it because it was coming from the second domain controller. He has signed it, and he has returned that signed certificate, and that is what we have right here. So what I will need to do now is to actually put this into a file. I need to copy it, then I can echo it entirely, decode it like this, and put it inside a certificate file, like this. So now we have our certificate. Let's see if we can verify that it is indeed a working certificate. We can do that with OpenSSL. It's a certificate containing both private and public keys. So I can do it like this, and then I think it's something like this. No, just no out, and there is no password. Okay, just like this, no password, where we can actually see that it works. So this is the thumbprint, I believe, and this is then the subject that is in here, so the CN, and this is the CA that has signed the certificate, and this is the certificate itself, right? So we can now use this certificate to request tickets, TJTs, from the second domain controller. So not this one, but this one. For that to work, we use Kerberos, and for Kerberos to work, I have to actually specify. Let's show you what I have done. I have specified these IP addresses within my host file. That's very important. You can of course also just edit the network configuration of your machine to point to this DNS server, or the second one if this is a DNS server, and then you don't need this of course, but it is fairly important that things like this work, that you can actually see an IP address. The ping must not work, but that you can see an IP address if you want to ping the domain, right? This is how Kerberos works, so that's very important. I already fixed that, and now we can try to get a ticket granting ticket. We can use the pkunit tools for that, and one of them is get_tjt pkunit.py. I'll just put it a little bit larger so we can see it a little bit better, maybe even larger still. So, so this is the username. It uses the certificate for authentication, and this is just to escape the $, because otherwise he would notice or try to read a variable name that is not there. So that's just to escape the command. And as you can see, it has worked. It was able to request a ticket granting ticket, a TJT, and it received an srep key. So we need that srep key. Let me already copy it. So and it has stored the actual ticket within the out.cache file, Ccache file. So this is the retrieving Kerberos ticket itself, and it is encrypted with this encryption key. That's how it works. Okay, so let's first export or create our variable to point to that Ccache file like this. And now we can use that key, that Kerberos key, with another tool called getNtHash to get the machine NT hash for that second domain controller, because we're still targeting that one. So how do we do that? Well, the same way that we just did it, like this. Hold on, it's like this. And then we need to specify the encryption key, which is this one, and then the IP address that we are targeting, which is this one. Oh, the second domain controller. Could also specify the name, not important right now. So this is still the username. It will use that Kerberos file, and this is the encryption key to decrypt the ticket. It has worked. It has requested the ticket from itself using a PAC configuration, and this would be the machine hash. Let's verify if that is indeed the machine hash for this machine, for this username. Like this, and we can specify the hash like this, and we have a plus, meaning that this is indeed the machine hash for that environment. Using that machine hash, we can now forge a ticket called the silver ticket attack, right? So for the silver ticket attack to work, we actually need something else. We need the domain SID, and as seen in earlier videos, we can get the machine ID using the lookup SID system, which is authenticated, but we have authentication now. We have the machine hash for our second DC. And this is something, well, we could have done it several ways, because you can see I now specified the FQDN. But the thing that we need here is this one. By the way, of course, it's lookup SID. It also shows us the user SIDs, and there are several right here. So what we need for the silver ticket more than anything else, we need the domain SID, and then we can use the one that we used before, the ticketer from Impacket, with the NT hash from the machine, which we have. Use this one like this. Yes, into that environment, the domain SID, which we have here like this. The domain name is also required. In this case, that's the one. And then we need our service principal name. We'll use a generic one, which is usually there. Demo.lan. And then a username, which is not that important, as you might already know. So it worked. So we were able to generate a silver ticket using the machine hash and the domain SID for that. Still only the second DC. We're not at the first domain controller yet, at the primary or main domain controller. But we have now our tickets right here. So let's switch it over to that new ticket. We can use this for this command for that, of course. Instead of the out.ccache, we now have our silver ticket within our Kerberos cache, and now we can use the normal ones like the SMB clients. With Impacket, you just specify -k to specify that you want to use a Kerberos ticket that is inside that variable. And let's see if this works like this. It works, so we have now full access to this second domain controller. Instead of SMB client, we can also do a secrets dump, for example. I think that's enough. As you can see, this works. It has performed a full domain sync. We see that the local administrator is empty, is not being used, but we have all our users here, and maybe one of those is the domain admin or enterprise admin. Let's see if our user Hubert might have something to do with this. So instead of, let's try it with this one, with the main DC user Hubert hash like this. Oh, like this, and oh, it works better if you don't make any typos, of course. And let's see if this works. If I'm not mistaken, it should work. It's slower than it should. Yes, we have our prompt. Okay, thank you, and keep learning.